Okay, let's give you guys some more practice. So in this video, I'm going to ask you to try and integrate this. So remember, when you differentiate the inverse sine of x, it will give you this thing here. It will give you this thing here, and we've done this many times. So by now you should know this by heart. So you should be able to get from here all the way down to here by heart. Okay, so you should know it by heart. So when you differentiate the inverse sine of x, it will give you this. But be able to do this by heart. So remember, let's just say y equals this thing, then you would sign equally to both sides. That would then give you this, and then use implicit differentiation. That would then give you this. Get dy by dx on its own. So that would then give you this. And then from here, so dy by dx equals this thing here. But then you would go back to here, and then use this to translate this bit here. Okay, so looking at this statement, so hang on, you are currently here at the moment. So you would go back to here and then look at this statement. Use this statement here to translate this thing here. So we've done this many times in the past. So set up a scenario. So looking at this, set up a scenario in such a way that this statement here is true. So if you look at a triangle, let's say the angle here is y. Let's say the angle here is y. Set it up in such a way that this statement is true. So let this be x. Let this length here be 1. So sine of y will equal the opposite over the hypotenuse, which is 1, which is sine y equals x, and then blah blah overall. So cos of y here, cos of y would be from here all the way up here. So cos of y equals this thing here, the adjacent, divided by the hypotenuse. Well, yeah. So it would be this. So then this thing here collapses. So that would then give you this. So 1 over cos of y would be 1 over this thing here, which would be, well, we've done this many times. So just remember that when you differentiate the arcsine of x, that would then give you this. So now I'm asking you to integrate this. So use integration by parts to integrate this. So press pause and have a go. Okay, so to do this, let's this whole. So imagine this as being like one block, and then you're multiplying with another block. This block here is the number 1. So let's u be this, and then let's v prime. So u equals that. Let's v prime equals the number 1. So let's v prime equals the number 1. Well, if v prime equals the number 1, then normal v would be x. So you would integrate it to get to here. If u equals arcsine of x, then u prime will equal this thing here. Basically, from here you would differentiate it to give you this. So now mindlessly follow this procedure here. It's saying get u times v. So it's saying get u times v. So that would be x sine inverse sine of x, and then you've got your minus the integral of, it's saying get u prime times v. It's saying get u prime times v. So that will then give you this, x over root 1 minus x squared dx. Okay, so this thing here will then take us to here. Will then take us to here. So now it's just a matter of integrating this. So remember, at this stage, our integration skill is still very weak. But one thing that we do know is that you should be able to spot that this thing here, you should be able to spot that this thing here is near enough the derivative of this bubble here. Okay, so even though at this stage our integration skill is very weak, we should be able to spot that this thing here is in a way the derivative of this thing here. Because alright, we are trying to integrate this. Well, if you look at this here, if you make this to be your initial guess, so make this to be your initial guess, hang on, So imagine this thing here as being x times 1 minus x squared to the power of minus a half. Okay, so this thing here, imagine it as like this. But when you integrate it, it's going to be one notch higher than this. The power is one notch higher. So one notch higher would be this, a half. Okay, so we are trying to integrate this. But what you should notice is that this thing here is near enough the derivative of this thing here. So make this to be your initial guess. Look what happens when we differentiate this. Look, hang on, let's go back one step. We are trying to integrate this. So really you're looking for something in such a way that when you differentiate it, it will give you this thing here. Okay, so we are trying to integrate this. Hang on. We are trying to integrate this. So look at this. If you differentiate this, it will give you something very close to this. Okay, we are trying to integrate this. So let's start with our initial guess. Make this to be our initial guess. Well, if this is our initial guess, then when you differentiate it, it will give you this. Watch this. Hang on. Differentiate it. It will be a half, and then the bubble stays intact, and then this thing here gets minus by 1. So that will give you minus a half. And then you've got to times with the derivative of the bubble itself. Well, the derivative of the bubble itself is minus 2x. Okay. So if you tidy this thing up, it will give you this. It will give you this, a half, and then times this thing here gets multiplied to the top. So it will be minus 2x over, and then don't forget, it would be this, 1 minus x squared here. It would be this. So you notice that this thing here is very close to this. So our integration is very close to this. But let's tidy this up. So the two 2's will cancel each other out, and then make the adjustment here. You've got a negative here. So if you make so this was our initial guess. If you make the adjustment to our initial guess, stick a minus into here. Now if you differentiate this, then this minus here will disappear. This minus here will disappear. Okay, so the integral of this will be this. So what you've got here, don't forget this minus will merge with this minus here, so it will give you a plus this thing here. So hang on. So we are currently here at the moment. If you integrate this, it will give you this. So this here is our final answer. Okay, because it just boils down to this bit here. So hang on. So we were trying to integrate this, and then we realized that if you differentiate this, it will give you something very close to this. But then you would make the adjustment. The adjustment is negative a half, negative 1 here. So well, integrate this. It will give you this thing here. Okay. So overall, our answer is this. Okay.